integration of 1 by x power 11 root of 1 plus x to the power 4 between the roots 1 by root 2 and 1. Any ideas? To apply substitution for 1 plus x to the power 4, I require x cube with dx in numerator. But if I try to provide that, this will become x to the power 14, not a integral power of x to the power 4. So, other idea that can be applied is, we divide numerator and denominator by, no, not dividing, just this expression, you divide by a certain power of x, and to balance that outside you multiply. Okay. We write the expression to be integrated as 1 plus 1 by x to the power 4. So, the expression inside the radical sign has been divided by x to the power 4. To balance, outside we must multiply by x square, and this expression, this factor will become x to the power 13. What is the advantage now? If we substitute for this expression, for applying the substitution, we will require 1 by x to the power 5 with dx in numerator. We can get it from here. Even after removal of that 1 by x to the power 5, left out portion will be x to the power 8, which is an integral power of the expression for which you are applying the substitution. That will be the advantage. Let us apply the substitution. T square equal to 1 plus 1 by x to the power 4. Expression under the radical sign in denominator becomes t, and minus 4 by x to the power 5 minus 4 by x to the power 5 dx will be 2t dt, or 1 by x to the power 5 dx will be 2t dt divided by minus 4, that is minus t dt by 2. You have taken care of this. You have taken care of dx by x to the power 5. Remaining is x to the power 8. And this x to the power 8 is, I can think it as not x to the power 8 as a factor of denominator. Let me treat it as 1 by x to the power 8. For the whole fraction, 1 by x to the power 8 is the remaining factor requiring replacement in terms of t. What is 1 by x to the power 8? Simply t square minus 1 whole square. This is to be written in numerator now. I find the integrand to be a very simple function. Okay, simultaneously I must replace the limits of integration also. When x is 1 by root 2, what will be 1 by x to the power 4? 1 by 4 plus 1, 5 by 4, t, square root of that. When x is 1, this thing becomes 2, t becomes. Okay. The substitution was not properly applied. X is 1 by root 2, so 1 by x will be root 2, 1 by x to the power 4 will be 4, plus 1, 5, t is root 5. Am I right now? Yes. When x is 1, this is 2, t is root 2. Let us interchange the limits. Integral becomes root 2 to root 5, half of t cancels, remaining portion of the integrand is t square minus 1 whole square, t power 4 minus 2t square plus 1 dt. Is a very simple exercise to carry out integration, apply the limits, simplify. Our next integral is pi by 6 to pi by 3 of sin square cos x by sin x minus cos x dx. Even though I have a cos x with dx in numerator, I cannot think of applying the substitution sin x equal to t, because there is a cos x with odd power in denominator, which if replaced in terms of sin x will give rise to an irrational expression. So, what other suggestion you can? Multiply numerator and denominator by, okay, a sort of conjugate of this, sin x minus cos x or cos x minus sin x, whichever is preferred. Then we will obtain pi by 6 to pi by 3 of, you are multiplying numerator denominator by cos x minus sin x. This will become cos square x minus sin square x, which is simply the expansion of cos 2x. Numerator will become sin x cos sin square x cos x into cos x minus sin x. Let me with dx. Huh. Okay, okay.
And one sin x will remain, half will remain outside.
Okay.
Then I split the integral.
Integrand.
It becomes
Okay.
yeah.
Fine, fine. Got your point. Got your point. So, you will be writing the numerator as sin x cos x into sin x into cos x minus sin x, which will be half of sin 2x into, portion remaining now is sin x into cos x minus sin x, which is sin x cos x minus sin square x. Okay, what are you going to do with that? What are you going to do with that portion? Break the integral. Okay, write it as sum of two integrals. One second. Okay, I will be following your policy only. Let me first carry out multiplication of numerator and denominator by cos x minus sin x. Let me write out what I am going to get. Denominator becomes cos square x minus sin square x. Numerator sin square x cos x into cos x minus sin x. I find that in this portion, the expression is sin square x cos square x by cos square x minus sin square x. Only even powers are occurring. There is a very simple procedure to get this converted into a function of standard form. Simply divide numerator and denominator by cos square x. Will it be enough? No. One second. Cos square x division will remove this. This will become 1. This will become tan square x. Not enough. Not enough. One second. The other portion is easily workable. This portion is sin cube x cos x by cos square x minus sin square x can be worked out with the substitution sin x equal to t. I had an easier method, but I forgot now going through this. Huh? ಏನು ಹೇಳಿ? ಹಾಂ, ಓಕೆ ಓಕೆ, ಹಾಂ ಹಾಂ, very good. Instead of going through all these manipulations, simply make use of one of the properties of definite integrals. Nice. That would have been the best method. Okay, what are we doing now? Apply the property integral a to b f of x dx equal to integral a to b f of a plus b minus x dx. The advantage here we have is a plus b is pi by 2. If we apply that property, the integrand becomes pi by 6 to pi by 3 of x is getting replaced by a plus b minus x. A plus b minus x is simply pi by 2 minus x, sin square of pi by 2 minus x cos square x, cos of pi by 2 minus x sin x, divided by sine of pi by 2 minus x cos x plus cos of pi by 2 minus x sin x dx. Suppose you call this I1, this one I2, you are finding I1 and I2 equal, therefore each must be average of I1 and I2, each must be equal to I1 plus I2 divided by 2. I1 plus I2, I1 and I2 both have same limits, same common denominator. The numerator becomes sin square x cos x plus cos square x sin x cos x common into sin x plus cos x, which is half of integral pi by 6 to pi by 3 sin x cos x dx or half of sin 2x dx, and integral becomes 1/4 of minus cos 2x by 2 to be evaluated between limits pi by 6, pi by 3. Good. Nice. Next, integration between 1 by 2 root 2 and 1 by root 3 of root x square plus 1 into log of x square plus 1 minus 2 log x divided by x to the power 4. Little bit of simplification of the integrand. 1 by 2 root 2 to upper limit is 1 by root 3. The function to be integrated, fraction with denominator x power 4, numerator root x square plus 1 into, simplify the expression inside, it is log of 1 plus x square by x square. Is it right? 1 plus x square by x square, correct. This now may be written as integral 1 by 2 root 2 to 1 by root 3. This is log of 1 plus 1 by x square. What will be derivative of 1 plus 1 by x square? Can you see it anywhere? Yes. Yes. To find derivative of 1 plus 1 by x square, which is minus 2 by x cube, I separate one part of this and write it outside with dx. ಉಳ್ದದ್ದು ರೂಟ್ ಒಳಗೆ ಹೋಗ್ತದೆ, ಅದಕ್ಕೆ ಬೇರೆ ದಾರಿಯೇ ಇಲ್ಲ, ಅದಕ್ಕೊಂದು ಜಾಗ ಕೊಡಲೇಬೇಕಲ್ಲ ನಾನು. Why should I first take x outside? First I reserve a portion required to bring in dt. What is required to bring in dt? I require x cube in denominator, derivative of 1 by x square minus 2 by x cube. So I provide provision for that. What remains in the denominator is x. I must place it somewhere. I will place it with this. Immediately we find a convenient substitution, workable substitution. The substitution we apply is 1 plus 1 by x square equal to t square. Integral becomes, this is log t square 2 log t. This is dx by x cube minus 2 by x cube dx is 2t dt. So minus 1 by x cube dx will be t dt. This is minus t dt. What about this portion? Root of 1 plus 1 by x square is t. Yes. New limits. When x equal to 1 by 2 root 2, 1 by x square is 8 plus 1 9, t is 3. When x equal to 1 by root 3, 1 by x is root 3 square is 3 plus 1 4, t is 2. Interchanging the limits, it becomes 2 into integral 2 to 3 of t square log t dt, which is obtained by the method of integration by parts. First function log t, integral of the second t cube by 3 minus integral, derivative of first 1 by t, integral second t cube by 3 dt. The limits 2 and 3 are to be used after finishing integration process. Integration between limits minus half of log root 1 plus x plus root 1 minus x. Okay, idea? Even function. First we observe that the integrand is an even function, so integral may be written as 0 to half log of root 1 plus x plus root 1 minus x. Very good. Then okay. Let me write down. 0 to half log of square of this. Square of this is 1 plus x plus 1 minus x, 2 plus root of 1 minus x square. Sorry. One second. Square has already been performed, so there is no need to write that here. Okay, 1 plus x plus 1 minus x plus 2 root 1 minus x square. Fine, good. Take 2 outside. Write it as log 2 plus log of 1 plus root of 1 minus x square. Fine. X equal to sin theta. Very good. So, it becomes integration of log 2 plus log of something. Integral log 2 is x log 2. When limits are applied, it becomes half log 2. Second term is integration of log 1 plus root 1 minus x square between the limits 0 and half. And your suggestion, use the substitution x equal to sin theta. Okay, when the substitution is applied, 1 plus root 1 minus x square becomes 1 plus root 1 minus sin square theta. 1 plus root cos square theta is 1 plus cos theta. Log of 1 plus cos theta into dx. Dx is cos theta d theta. New limits of integration. When x equal to 0, theta is 0. When x equal to half, theta is pi by 6. What next? Pi by? Are not our limits 0 and half? Yes. When x is sin theta, can't be pi by 2, it must be pi by 6. Okay. Up to this step, I have no objection. I will retain it as it is, not up to that step. Even this portion I will retain. The other portion I am not using this substitution. Let me write the previous expression as it is. It is 0 to half of log of 1 plus root 1 minus x square dx. What next you may try is integration by parts, taking the function itself as one function and one as second function. Let us try, let us see what happens. It will be half log 2 plus first function log 1 plus root 1 minus x square into integral of the second x minus integral of derivative of the first is 1 by 1 plus root 1 minus x square into derivative of root 1 minus x square is 1 by 2 root 1 minus x square into derivative of 1 minus x square minus 2x into integral second x dx. The new limit, the limits of integration 0 and half, no change. Is this a sufficiently simple function, easily integrable function? Just check. At least it is free from logarithmic function, must be simpler to integrate. It must be simpler than this function to carry out integration. What method can be tried? Just think of 2 cancel. This minus can be taken outside. Okay. Numerator is x square. Denominator is this much. 1 minus. Okay. X equal to tan theta. You can't try. Sin theta, cos theta, okay, usable. Any other idea? Okay, I'll go for that substitution, sin theta or cos theta, only as last choice. Before that, any other choice, any other option? Suppose I use a substitution like 1 plus root 1 minus x square equal to y. Suppose I am just making an attempt. What will be 1 minus root 1 minus x square? What is 1 by y? Okay, I will find that later. What is 1 by y? 1 by 1 plus root of 1 minus x square. Suppose you rationalize the denominator. What happens? 1 minus root 1 minus x square divided by x square. Usable in any manner? I don't know. Just find out. No idea? Why multiply? Let me change the substitution. Instead of 1 plus root 1 minus x square, let me use 1 minus root 1 minus x square. What will be 1 by y? 1 by root 1 minus x square. When you make the denominator rational, denominator will be x square, numerator will be this. Do you find this somewhere? Yes. Does this account for this portion? Yes. How do you take care of this portion? This comes under dy by dx. Agreeable? Huh? Which x remains? The x that you obtain when you differentiate this, there will be one surplus x. That will remain. How do we account for that? Okay. It will be another problem, serious problem. Yes. Yes. Rationalize and okay, numerator becomes 1 minus root 1, break the integrand. Fine. Application of limits gives some number minus half minus integral 0 to half of. Keep the second denominator unchanged. Rationalize the first denominator, multiplying numerator and denominator by 1 minus root of 1 minus x square. Denominator becomes x square. Here you had one x square. This x square and this x square cancel. You are in a position of breaking the integrand as 1 by root 1 minus x square minus 1, each term immediately integrable. Fine. Actually, my method was direct apply the method of integration by parts to the original function itself, taking 1 as the second function. It would have worked. I don't know whether you would have obtained the answer more quickly, but the method works. I have tried that. I have one more problem, I think. Yes. This one. Okay, you write it in denominator, no problem.
Tan power 11 by 3 is
Let me write down. Sin power 11 by 3 into cos power 1 by 3 dx. Okay. My suggestion will be, you multiply numerator and denominator by sin power 1 by 3. What will happen? You will get a sin power 1 by 3 here, and this will become sin power 12 by 3. Sin power 12 by 3 is sin power 4. What is the advantage? You can see one tan here. Together with that, you are finding a cosecant square here. Do you get it? Cosecant power 4x divided by cot power 1 by 3x dx. Using the substitution cot x equal to t cube, denominator is t, 1 cosecant square you require with dx to bring in dt. The extra cosecant square is 1 plus cot square. What is cot square? T power 6. Agree. And remaining cosecant square with dx is minus of 3 t square dt. New limits are, when x equal to pi by 6, cot pi by 6, root 3. When x equal to pi by 4, cot pi by 4, 1. Is this not root 3? Should it be 1 by root 3? I don't know. Cot x equal to t cube. Okay. It should have been, our substitution should have been, substitution is okay. You mean the lower limit. Fine. Okay, x is pi by 6, so cot pi by 6, 1 by root 3 is t cube. It should be cube root of what I wrote earlier. That means 6th root of 3. Right. Correct. What about this? No problem. Fine. And it's a simple exercise. Yes. help. We find the integrand composed of two parts. One part more complicated, one part less complicated. More complicated part certainly deserves substitution, but I cannot apply substitution for this because I am not finding x power 9, I am not finding x power 4. Make some adjustment. Remove one x from here and take it inside this. When taken inside the second bracket, it becomes x to the power 5 inside. For this function, do you find this as the derivative? Not exactly, but a numerical multiple. Agreeable? Am I right? New limits when t equal to 0, when x equal to 0, t is 0. When x equal to 1, t is 2 plus 3, 5 plus 6, 11. Next, 0 to 3 by 4, x plus root of x plus root of x square plus 1. Simply go for the substitution x plus root x square plus 1 equal to y or y square. How to find dx? That question may arise. Before finding x, I will obtain a simple expression for x. How do I obtain it? Just consider 1 by y square with this y square value. It will be 1 by x plus root x square plus 1. When you rationalize denominator, it becomes x minus root x square plus 1 divided by minus 1, or it is minus x plus root x square plus 1. How do I obtain an expression for x? Simply from this subtract this. We will be getting x as half of y square minus 1 by y square. So what is the replacement for dx? You can easily obtain it now. My integral becomes integral y into dx. dx is half of derivative of y square 2y minus derivative of 1 by y square minus 2 by y cube dy. New limits when x equal to 0, y square is 1, y is 1. Upper limit when x equal to 3 by 4, 9 by 16 plus 1, 25 by 16, root is 5 by 4, 5 by 4 plus 3 by 4, 8 by 4, 2, y square is 2 means y is root. Is it simple enough to integrate now? Yes. Again, simply consider this x plus root 9 plus x square and try a substitution for that. What will be dy then? 1 plus, now I will not be going for x minus root 9 minus 9 plus x square. I have a required root 9 plus x square in denominator. I have to take care of that. Simply differentiate 1 by 2 root 9 plus x square, numerator 2x into whole into dx is equal to dy. When you simplify this expression, denominator root 9 plus x square and numerator becomes root 9 plus x square plus x. This is an expression needed to bring in dy. So, what will be our integral? Keep 1 x plus root 9 plus x square in reserve, that is required to bring in dy. Remaining portion is y to the power 9. The remaining x plus root 9 plus x square divided by root 9 plus x square dx is dy. The new limits are when x equal to 0, root 9, 3. When x equal to 4, 4 plus root 13. X is 4 means this is 16. Plus 9, 25. Root is 5. 5 plus 4, 9. I have promised all problems of this. These are two simple problems. Next one. Integration from 0 to pi by 4 of tan inverse 2 cos square theta by 2 minus sin 2 theta secant square theta d theta. We will write the integrand as tan inverse. This may hint you at one stage or the other, the substitution tan theta equal to t is going to be used by you. Let us try to bring in tan theta here. I will write this cos square theta. Okay, I will keep it as it is. Write this as 2 sin theta cos theta. Then divide numerator and denominator by. My objective is to bring in tan theta. Get rid of all sin and cos. We will divide numerator denominator by cos square theta. Okay. We will have 2 goes away on cancellation. So, numerator 1 by secant square theta, 1 by secant cos square theta is secant square theta. The other part sin theta cos theta by cos square theta is tan theta. Agreeable? Or completely expressed in terms of tan theta, it is tan inverse 1 by tan square theta minus tan theta plus 1. If you use the substitution tan theta equal to t, it becomes tan inverse 1 by t square minus t plus 1 dt with new limits. Tan theta is t. Tan 0, tan pi by 4 are the new limits. Okay. How to get this integrated?
1 plus t into t minus 1. And you can split as 1 by t minus 1 minus 1 by t. That will be tan inverse x plus tan inverse y form. So we take that.
Yes. We will write this as denominator 1 plus t into t minus 1. Numerator t minus 1. Just to see the expression in the form tan inverse of a minus b by 1 plus ab. Once you see the expression in that form, you will be able to apply one trigonometric identity. You will be able to break the integrand as tan inverse a minus tan inverse b. how to get the job finished? Integrate by parts. In each case, apply the method of integration by parts, taking 1 as one of the functions. Yes. Over. Any idea? Any advantage? What about that secant x? Simply apply tan x by 2 equal to t. It will be a bit lengthy problem, I admit. The integral becomes tan 0 by 2 lower limit 0, tan pi by 4 upper limit 1, dx is 2 dt by 1 plus t square divided by 2 plus sin x is 2t by 1 plus t square whole square, and it becomes 0 to 1. In denominator I am having a 4. After removal of 2 from numerator, it will be 2 in denominator, dt by, 1 plus t square will go to the numerator, 1 plus t square dt by square of t square plus t plus 1. To continue from here onwards, what I suggest is, try to simplify the integrand. First, you add and subtract a t from numerator. One portion you will be able to write as 1 by t square plus t plus 1, which can be immediately finished going through the method of completing squares. The portion remaining will be t by t square plus t plus 1. That, what I do with this is, will be written as half of 2t plus 1 minus half. In denominator I am having a square. This is what I am having. I will write the numerator as derivative of this quadratic in denominator into a number with constant term adjusted. Now this portion can be easily handled through the substitution t square plus t plus 1 equal to y. Numerator dy, dy by y square, immediately finished. Last portion remaining will be of the form some constant by square of t square plus t plus 1. How to handle this now? Constant I have kept outside. Once you attain this stage, my suggestion would be you write this applying the method of completing squares as t plus half whole square plus 3 by 4 again to be square. Apply substitution t plus half equal to root 3 by 2 tan theta. When that substitution is applied, what will happen to the integrand? Denominator will become 3 by 4 tan square theta plus 1 within brackets is 3 by 4 secant square theta when squared 9 by 16 secant power 4 theta. Agree? What about numerator? Numerator is dt, t plus half is root 3 by 2 tan theta, so dt will be root 3 by 2 secant square theta d theta. One secant square theta gets cancelled, another secant square gets shifted to numerator as cos square. It will be written as 1 plus cos 2 theta by 2 term by term integration. Job is finished. Okay. Go on reducing the form of the integrand until you get a sufficiently simple form at the end. And at that moment you will go through, we will be applying one substitution. Method is clear, I suppose. You can attempt this later. Or if there is any alternative, you can think of that also. Very normal problem to be worked out using the method of substitution. The substitution is clearly this equal to t cube. But one small choice may be, one small advantageous choice, a choice which may help you little more maybe. Suppose you take it as it is, when you differentiate, you get a fraction with 2 plus x whole square in denominator. You do not find that here. Instead, you are having 2 minus x here. So, instead of choosing 2 minus x by 2 plus x to be t cube, you choose the reciprocal 2 plus x by 2 minus x to be t cube. Now, you will be able to completely get this product 2 minus x whole square in denominator together with dx. Get it replaced by dt and the integrand gets completely simplified. It will be a very simple exercise to carry out the integration. So, this may be more ideal to use in that situation. Even the reciprocal works, this is better. Simple one. Numerator is simply pi by 2. How do you see it? The first term in numerator is sine inverse of 2x by 1 plus x square. It is this angle. Sine inverse of 2x by 1 plus x square. What will be the size of this side? Root of this square minus this square. 1 minus x square. So, what will be cot inverse 2x by 1 minus x square? Cot inverse 2x by 1 minus x square will be this angle. What is the sum of the two? Okay. Numerator is pi by 2. Denominator 1 minus x to the power 4. Resolve into partial fractions. One will have denominator 1 minus x square, other one 1 plus x square. Carry out integration. Zero to 4 sine inverse root of x by x plus 4 dx. Don't think anything else. Directly apply substitution for that integrand. I will put theta equal to sine inverse root of x by x plus 4. Let me see what happens. Sin theta is root of x by x plus 4. X by x plus 4 is secant sine square theta. So what will be x? Okay, take reciprocals. X plus 4 by x is cosecant square theta. This is nothing but 1 plus 4 by x. So 4 by x is cosecant square theta minus 1 cot square theta. So what is x? X is 4 by cot square theta. Am I right? Or is equal to 4 tan square theta. Okay? You can find a replacement for dx easily. Integral becomes sine inverse root x by x plus 4 is theta, and dx is 4 into 2 into 8 into tan theta into secant square theta d theta. New limits of integration. When x equal to 0, this is 0, sine inverse 0, theta is 0. When x equal to 4, this is 4 by 8, root of 1 by 2, 1 by root 2, sine inverse 1 by root 2, pi by 4. How to get this integrated? Parts. First function, second function. Is not this easy enough to integrate? Yes. What is the integral? Tan square theta by 2 minus integral of derivative of first will become 1. Is it clear? Split. Correct. 0 to pi by 2. X by 1 plus cos x is x by 2 into secant square x by 2. Am I right? 1 plus cos x is 2 cos square x by 2. X by 2 cos square x by 2 is this. Plus other part. Other part keep it as it is. No simplification needed. Sin x by 1 plus cos x. Integrate by parts. Integrate using substitution. Very simple. Write the integrand as 0 to pi by 4 of tan power 5 into tan square x broken into 2 pieces secant square x minus 1. This part immediately gets integrated. Next part, again write it as tan cube x into secant square x minus 1. Tan cube x will remain. Write it as tan x into secant square x minus 1. Job gets finished. These limits are, yes. Okay, let us take the advantage, break the integrand. Minus pi to pi, 2x by 1 plus cos square x plus minus pi to pi 2x sin x by 1 plus cos square x. Is this an odd function? Yes. This is an even function. So what remains is twice 0 to pi 2x sin x by 1 plus cos square x dx. This 2 could have been written together with this. Okay. Now, it's a mixture of trigonometric and algebraic. You are familiar with such situations, not parts. Use of the property 0 to a f of x dx equal to 0 to a f of a minus x dx. What happens to the integral 0 to pi x sin x dx by 1 plus cos square x? If you apply that property, you get the integral is 0 to pi of pi minus x into sin of pi minus x is sin x by 1 plus cos square of pi minus x cos square x dx. What next? Add. This is I1, this is I2. They are equal. Each is equal to I1 plus I2 by 2. While you add I1 and I2, this x, the part containing x will get cancelled. You will be left with pi sin x by 1 plus cos square x, which is easily integrable through substitution cos x equal to 2. To find I1 by I2, you need not determine individual value of I1 or I2. What you require is just the ratio I1 by I2. No need to waste your time in individually computing I1 and I2 separately. I think it may not be possible also to determine individual values of I1 and I2. Okay. Find a relationship between I1 and I2. Among the two integrands, which you find is more complicated, I2. Let us try to bring I2 to this form. You want in denominator 1 plus x. So, this denominator, you want this to get converted to 1 plus t. Apply the substitution t equal to 1 minus x cube. What happens? I2 becomes, denominator 2 minus x cube becomes 1 plus t. E to the power x cube will now be e to the power 1 minus t. Agree? Numerator x square dx will be minus 3x square dx is dt. So, x square dx is minus dt by 3. Am I right? Yes. New limits, when x is equal to 0, t is equal to 1. When x is equal to 1, t is equal to 0. Interchange limits, 1/3 of 0 to 1. What is this? This I may simplify as e to the power t dt by 1 plus t. There is one more factor in denominator, e is a constant factor. I will write it outside. Over. Next, f r to r is differentiable, f of 1 is 4. What is limit extending to 1 of integral 4 to f of x 2t dt by x minus 1. Notice that here integration is to be carried with respect to t, and one part of the integrand is x minus 1. We will treat this x minus 1 as a constant as far as this integration job is concerned. So, we may write this as limit extending to 1 of denominator x minus 1. Separate that x minus from the integrand. Numerator is integral 4 to f of x 2t dt. Right. Apply the usual procedure that you first use while evaluating limit. Substitution method. Denominator 0. Numerator, this becomes f of 1. But what is f of 1? Is given to be 4. Integral 4 to 4 is 0. You are getting indeterminate 0 by 0. What is the alternative? L'Hopital's rule. 1. Derivative of numerator 2 into f of x into f prime x. Apply the values, answer is obtained. What is that we have to find? Is not f prime given? No, we are given only f of 1. I think I didn't copy it. Right. Okay, answer is to be given in terms of f dash only. One more error of mine. You are applying limit as extends to 1. The process has not been finished. I must retain it here. And when you apply the limit, it becomes 2 into 4, 8 into f prime 1. That's all. Okay. Then find A if x is this much and d square y by dx square is ay. Given x as an integral with upper limit y, to find given d square y by dx square is ay to determine a. First, simply differentiate the two sides with respect to y. You will be getting dx by dy. You will be getting dx by dy as 1 by root of 1 plus 9y square. Agreeable? Yes. This simply means dy by dx is root 1 plus 9y square. Therefore, what is d square y by dx square? It will be half of to the power minus half 1 by root 9 plus y square into derivative of 9y square 18y into you are differentiating with respect to x, not with respect to y, dy by dx. But you know dy by dx is root 1 plus y square. Apply that, you will be able to read the value of a. Okay. Given integral sin x to 1 t square f of t dt is 1 minus tan x, to find f of 1 by root 3. You are required to obtain the value of f at a certain point. Let us release this side from this integral sign. How to get the integration sign removed? Differentiate the two sides with respect to x. Left side derivative with respect to x is minus sin square x into f of sin x into derivative of sin x cos x. Derivative of right side minus secant square x. From this I am able to write f of sin x is equal to some simplification. Yes. Yes. 1 by cos cube x into sin square x. Am I right? Is it wrong? Okay. But my objective is to determine f of 1 by root 3. How do I get it now? Just to find the point where sin x equal to 1 by root 3. Apply that x value in the right hand side. So, what I am required to find f of 1 by root 3 will be simply the value of the right side when x is a number such that sin x equal to root 3. You are having sin x equal to root 3. For this x, sin ratio opposite by hypotenuse 1 by root 3. What will be the adjacent side? Root 2. Therefore, what will be cos x? Root 2 by root 3. What will be the cube? 2 root 2 by 3 root 3. What is sin square x? 1 by 3. Okay. Right. ಎಷ್ಟು ಟೈಮ್ ಉಂಟು? 1, 2, 3, 4 problems. I will finish off because that will complete that this chapter. ಸ್ವಲ್ಪ ಲೇಟ್ ಆದರೆ ಅಡ್ಡಿಲ್ಲ. We'll be finishing tomorrow. Only 4 problems remain. Let us finish off these 4 problems and then discuss. Simple problems again. Only to have a wider variety, I have included these problems. That's all. One problem remains, I will write it later. Simple one. First we find the slope of the tangent. What is slope of the tangent? Dy by dx. Dy by dx at x equal to 1. What is dy by dx? Dy by dx is 1 by root of 1 plus x to the power 6 into 3x square minus 1 by root of 1 plus x to the power 4 into 2x. This is dy by dx. So, what will be dy by dx at x equal to 1? The slope of the tangent that we are required to draw. It will be 3 by root 2 minus 2 by root 2. 3 by root 2 minus 2 by root 2 is simply 1 by root 2. This will be the slope of the tangent. The point where the tangent is drawn has x coordinate 1. What will be the y coordinate of the point where you are going to draw the tangent? Apply x equal to 1. 0. Lower and upper limits are equal. Y coordinate of the point where you are drawing the tangent is 0. X coordinate 1, y coordinate 0, slope this much, write the equation of the tangent. Finished. Find the value or values of x at which function attains its minimum. What is the requirement? What is the condition that a function may attain a minimum, local minimum? First derivative 0, second derivative negative, provided the function is differentiable. Is your function a very differentiable? Yes. If there is a point where function is not differentiable, don't forget that point will not be covered by your conditions of maximum minimum. You will have to handle that point individually, separately. Okay, in this case function is differentiable. Derivative will be simply x into x minus 1 into x minus 2. What are the critical points? 0, 1 and 2. Okay. Among those critical points, which may be the minimum points for the function, you need to find the second derivative. What is second derivative? X into x minus 1 plus x minus 1 into x minus 2 plus x into x minus 2. You find out at which of the critical points this second derivative is positive or negative? Positive. For local minimum, first derivative 0, second derivative positive. That's finished. Next. F of x is e power x by 1 plus x, 1 plus e power x. I1 is this, I2 is this. What is the ratio I1 by I2? The only crucial thing that is most important, that is the point to be noted, is what is f of a plus f of minus a. This is nowhere asked with you, but that is required in order to finish the job more quickly. F of a plus f of minus a is e power a by 1 plus e power a plus e power minus a by 1 plus e power minus a. This is, leave the first thing as it is. Second thing is 1 by e power a plus 1. What is the sum equal to? How do you take the advantage of this? Simply apply the property integral a to b f of x dx equal to integral a to b f of a plus b minus x dx. In this case, a plus b is 1. Apply that property in only one of the two places. I will apply it in this place. In I1, I will apply that. I1, applying the property is f of minus a to f of a. X is getting replaced by a plus b minus x is 1 minus x into g of x becomes 1 minus x and 1 minus x becomes x dx. So what? This means I1 is simply 1 into this is I2 minus x into this is I1. I1 is equal to I2 minus I1, 2I1 equal to I2. What is I1 by I2? That is your question. Okay. One problem. To finish the discussion, one very difficult problem. Okay. Thank you.